We'll do some more problems with percentages. What kind of problems? Well, more practice. Finding the original amount, but the fast way. You know how to find the original amount, remember? We used to do, well, this is what we're trying to do. We're trying to find what the original amount. We don't know what this is. We do know that we're increasing it by a known percentage. And we do know what that known amount or the known increased amount is. So we know this, but we need to know what the original amount was if we did this to it to produce a new amount. So let's look at that. Here's the original amount, and we don't know how much it is. But when we increased this by 20%, if we increase this by 20%, that's this much here, we got 18 clocks. So the new amount is 18 clocks. Now we know that if the original amount was 100% and you increase it by 20%, then the new amount is going to be 120% of whatever it was, right? So if we say 120% of the original amount is 18, then it's not so complicated because 1.2 times what is 18? That's what we're trying to figure out. And we know the best way to do that is divide 18 by 1.2 and we get 15. And that's the answer. The original amount was 15. And you can check. If you increase this original amount by 20%, which is 1/5, then you'll increase it by 3 and you'll get 18. That's the answer. Okay, so now that you know how to do this, let's try this one. You try it. You don't know what the original amount is. You know that it's gone up by 56% and the new amount is 962. What was the original amount? What will you do? Right, you know that the new amount, if the original amount was 100% and you increase it by 56%, then the new amount has to be 156% of the original amount of this. This means this is increased to 156% of the original. So 156% what? What's this? Of, yes, of this, of the original amount, is 962. And the moment you've got this statement, the rest comes easy because this is 1.56, this is multiplied by, and of course, what do you do to find this answer? 962 divided by 1.56. Do that on your calculator and your answer will come to 616.7, which is the correct answer. That was the original amount. If you increase this by 56%, that's what you'll get, 962. Try another one. What about this one here? What's the original amount? We know that's supposed to be 100%. If you decrease it by 35% to get the new amount, which is 312. Take it away, all yours. Right. What you know is, how do you fill this in? What goes over here? Yes, from 100 you took away 35%. That means the original amount, 100%, is being reduced to 65% of the original. So 65%, what do you put there? Of, and what do you put here? We don't know, that's a question mark. Of this is 312. And to find the answer, well, we know this is multiply, that's 0.65, and so what do you do? That's right, 312 divided by 0.65, and hit those buttons on the calculator and you'll get your answer as 480. There you go. That's how we do these kind of problems. They're very straightforward once you know what to do, how to handle it. Here's another problem. A computer sells at $250. It sells, that's the selling price. Okay, so let's put down the selling price. And during the summer sale, the price was discounted. It means it was reduced. So this is the selling price. The discount is shown here. It was discounted by 40%. What was its sale price? Well, computer sells at $250. That's this price here. It was discounted by 40%. That means you take out 40%. So if this was 100%, we would find out what the sale price is, right? So if this was 100%, the sale price must be, well, it's 60% of the selling price because it was reduced by 40%. All of 100% was reduced by 40% to 60%. So 60% of the selling price must be the sale price. And that's easy to work out. 0.6 times 250, which is $150. That's your answer. So the sale price is $150 if you give a discount of 40%. Okay, Mariam won a race by reducing her previous record time by 12%. Now, the previous record time she reduced by 10%. That means we don't know what the previous time was, but we knew that when she reduced it by a certain amount, by 10%, she got the final race time, the finished or the present race time, which is 172.8 seconds. You see, you set it up like this. The previous time minus the reduction gives us the present time. Now we know the previous time was reduced by 10%. We know the present time is this. And since if the previous time is seen as 100%, then 100% take out 10%. That means it must be 90% of the previous time, the present time. Since it was reduced by 10%, it should be 90% of the previous time, not all 100%. So 90% of the previous time, which we do not know what it was, equals to 172.8. So that's 0.9, that's times this equals this. Divide this by 0.9 and we have the answer 192 seconds. That was the previous time. There you have it. You get the feel of it? That's good. Okay, try this one. My rent was increased by 30% since March. I'm now paying $400 a week. So where do we start with? Do we know what the rent was before paying the increase? We don't. We know it was increased by 30%, so what do we write here? Here, we don't know what the original rent was. We know it was increased, we know that. So how much was it increased by? 30%. We also know how much we're paying now after the increase. So right now, we're paying $400 a week, which is at the present. And how much rent was I paying before March? That must be here. Before March, I was paying how much? We don't know. But suppose your original rent was 100%. If that was 100%, you're now paying 130% of the original rent or the previous rent. Right? So work it out. Very good. 130% of what? Of previous rent. Very good. And then what do we do here? 130% of the previous rent. Anything else we have to say to turn this into a complete mathematical sentence? Yes, is equal. It has to be equal. There you go. So 1.30 times how much is equal to 400. Now what do we do to find this? Very good. Divide 400 by 1.3 and we get the answer 307.7. So that must have been the previous rent, 307.70 cents. $307.70. There you go. And what about this one? A journey of 150 kilometers was increased by 30%. Okay, let's see how much that becomes, because this is a complicated problem. By what percentage should the new distance be decreased to make it 150 kilometers again? Okay, let's start with what we know. 150 kilometers was increased by 30%. This was the original distance, right? 100%. It was increased by 30%, so that means 150 becomes what? What do we do here? Who can tell me? If we want to increase the original by 30%, what do we do? That's right, we take 130% off the original because there's an increase from 100 to 130%. So that's right, 130% of 150 kilometers will be the new distance. Okay, so now that you've got that, you do 1.3 times 150, and the answer is 195 kilometers. That is the new distance. Now, we want to find out by what percentage should this new distance be decreased to make it 150 kilometers again. We want to bring this back or reduce it to 150 kilometers. So by how much do we reduce this to 150 kilometers in terms of percentage? But what percentage of this do we decrease to make it 150? Well, then we have to treat this now as the original, and this is the new decreased amount, and the percentage is how much in terms of decrease. Find the difference between the original and the new. The difference is, and then divide it by the original, and then multiply that by 100%. That's how we find the answer. So 195 minus 150 is 45 over the original, which is 195. And so this becomes 45 over 195, reduce that, becomes 3 over 13, so that's 300 over 13%. And if we turn that into a mixed fraction, we'll get 23 and 1/13%. If you want, you can also write it as a decimal. Not a problem. So that's your final answer. And there we come to the end of this exercise. Go over this again if you need to, but these are the kind of problem solving that you'll need to do, and you have to develop a way of thinking about it. You already have the tools, you have the rules, you have the understanding. Shouldn't be a problem at all. So have a great day, enjoy the fact that you're gaining a lot of confidence in understanding percentages. Take care, have a great day. Bye-bye.